So to solve proportional problems, it's really important to remember that proportions are times and divide, not add and subtract. So here, although this is not a nice proportion, our multiplier is going to be a decimal. To find any multiplier, we divide. So 22 divided by 5 is going to give me 4.4. So then that becomes my multiplier out here. So our multipliers don't always have to be nice in proportions. In fractions, we want nice whole number multipliers, but in proportions, we don't need that. Okay, because we know that proportionally, it's going to be 2 to 5 is equal to 8.8 to 22. Okay, so that multiplier is our scale factor here. Okay, so that's our scale factor is times 4.4. So here we could do the same. We can divide. Okay, so dividing 12 divided by 5. We could do it the other way around, but I'm going to do 12 divided by 5. We're going to get 2.4. Now this is not a multiplier, this is a divisor, but still a factor. And to solve this one, we're going to use the same factor. So divide by 2.4. It's really important not to subtract, because proportions are not about subtraction and addition. They're about times and divide. So although this is not a nice number, we're going to do 7 divided by 2.4. And it's going to give us a really messy looking number, but this is the number that we need. It's approximately 2.92, approximately. So these are scale factors that are going from left and right. Now we have our unit rates that go up and down as well, which we could have used. So this one here, we could have times by 0.4, and that would give us the same answer if we times that by 0.4. This unit rate is not nice because of that 7. Okay, so a map has scale factor of 50 kilometers to 3 centimeters or 3 centimeters to 50 kilometers. So we could use a proportion to solve this. Okay, so we can set it up as something like this. 3 centimeters, our map scale to our distance, is equal to our map scale to our distance. Okay, and solve it like that. However, we've started using this times and divide strategy. So if I want to find out the centimeter distance, I can start off with 338 kilometers, and then I can use my proportion to solve this problem as a multiplier, using this as its multiplier. Essentially, we're in an abstract way, we're using the unit rate. And so to make this work, I just need to make sure that my units cancel out. So kilometers on top should cancel kilometers on bottom, and we're going to be left with 3 centimeters on top, the centimeters units on top. So times on top, divide on bottom, we're going to end up with 20.28 centimeters. Okay, so there's our map scale for 1. If I want to solve for the actual distance when I start off with a map scale of 2.5 centimeters, again, if I want to make my units cancel out, I put my centimeters on the bottom, those cancel, and that's going to give me an answer in kilometers. So if I do 2.5 times 50 divided by 3, I end up with 41.6 repeating. So I'm going to round that to 41.67, and the units are kilometers, is which I'm looking for. Okay, so this is going to be the actual distance for a map scale distance of 2.5 kilometers. And again, we can use this proportional equation, but we've now started to develop this other strategy of unit analysis. For similar triangles, we are using the same proportional concepts, times and divide. We can set up a proportional relationship. So if these 3 triangles are all equal, we can say that this ratio of 4 to 5 is equal to 6 to 7, or 7, in this case 5 to 4.4 is equal to 7.5 to 6, which is equal to A to C. And we can make these sort of comparisons for these triangles. And now we can do the proportions 2 ways, remember, because there's a multiplier this way and a multiplier vertically. we can do it within the triangle, or we can make a scale factor between triangles. So for example, there is a scale factor here of times by 1.5. Okay, and we can see that from here to here. Okay, so we're going to find the ratio of the sides in fraction and decimal form and then solve for the unknown parts. So I'm going to do this first one comparing two sides of the same triangle. So I'm going to do 12 to 13. So that this side here, B to C, is going to be x to 4. Okay, so this is a ratio within the triangle, and I can cross multiply it, and I'm going to get 48 over 13 equals x. So I'm going to say x is approximately equal to, what's 48 divided by 13 gives us 3.69. So it's approximately 3.69. That's about right, because if this is 4, this is going to be a little bit less, because that's 13, a little bit less is 12. I'll do the same thing for y. I'm going to say y compared to 4. So this is comparing two sides of the same triangle. And I'm going to compare the same two sides. So 8 compared to 13. And again, we're going to cross multiply this. So we get 32 over 13. And y is approximately equal to 32 divided by 13 gives us 2.46. So it's not a really nice number, but again, we know the math is correct because we use a times and divide relationship. Okay, for the last one here, I'm going to use a scale factor going from here to here. So there's a divide by 6 scale factor when I compare these two here. So I see this is 2 to 12. Okay, and I'm going to say that that's equivalent to f to 8. Okay, so it's a divide by 12, divide by 6 scale factor here. So there's my scale factor that shows up vertically in the way that I've set it up. So 8 divided by 6, I get f is equal to 8 over 6, which is approximately equal to 1.3 repeating. Okay, and I'll do the same thing for g. I'm going to do my scale factor 12 to 2 to 12 is equal to g to 13. And there's a divide by 6 scale factor involved in this. Okay, and solving for g, okay, g is going to be 13 over 6, which is approximately, so 13 divided by 6 is 2.16 repeating, so I'm going to round that to 2.17. Okay, and that's an approximation. So those are my lengths here, 1.3, 2.17. Okay, that makes sense. That's a slightly longer than that. Slightly longer than that side here. Okay, and then my other for the green triangle here is going to be those two values.